This is a presentation for the OSTARA water bucket model. Please see the website first if there is any problems with the model, if you want to know a little bit more about the model, or see this video tutorial if you want to understand how it works. First of all, we open the model. Please enable macros, enable all content, downloadable content into the when opening the model. So to start, you go here and click here to start. It will prompt you into our land use page, in which you can change different land use scenarios to see whichever you want to analyze. So for instance, we can say we want to analyze intensive agricultural activities, and with this we move along to additional conditions. In the additional conditions tab, you can change the weather conditions in the soil and existing and future soil moisture conditions, either by going up in evaporation rate or going down to it, as well with the rainfall. And with the same goes with the base flow and the infiltration capacity of the base flow, going from 0 to infinite, and the infiltration capacity from 0 to 100. With this required information, you go and click run, and this will prompt a little screen saying that the calculations have been ran. And after a little while, you're going to be prompted into another page in which it shows the original given data for the analysis, and then the calculations that were done for the analysis, and an error distribution for the calculated versus observed graph. If you see anything in this page that you don't like, you can go back to either land use or to additional conditions and change these parameters running again, so you can update some information. If you're okay with this, you can move back to data calculations and then look at results. The results page shows a comparison graph between the calculated flow and the observed flow, as well as the precipitation event on the top of the screen. It shows relative error distribution. That's how distributed the items are for each calculated flow, and simulated versus observed discharge plotting event with polynomial distribution, so we could see the coefficient of determination. If you want to see other dates, you can select whichever dating range is the best for you or for your results. And when you're good with this, you want to see maybe how efficient the program is. So this is where the Nash-Sutcliffe efficiency comes from, which is just a parameter to determine if the hydrological model is adapting or performing well in comparison to the observed data. A flow or a calculated flow, which is a Nash-Sutcliffe efficiency, which is closer to 0.6 or 0.5 or onwards, is said to be a very good and reliable model. If you want to save the results for the first run, you click here and save results. This will publish this into a PDF file, and later you can save it whatever you are required. You close this, and then maybe you want to analyze what happens with the same existing results, different waveform information, infiltration capacities, click run again, you look at the results and you see there's a change in the Nash Sutcliffe efficiency. There's a bit of adjustment with some parameters. Again, want to save the results for the existing leads. You go here, save results, and you save the second run. For future reporting. And this is the demonstration for the OSTARA water bucket model. Please, if there's any questions, troubleshooting, visit our website or put yourself in contact with our information in the website. And thank you so very much for using our model.